So good morning, chemistry second year, English medium. So our unit is organic compounds containing carbon, hydrogen, oxygen. And the topic is alcohols. Already in the previous class we discussed what are the carbon, hydrogen, oxygen containing compounds. So that is alcohols, then phenols and ethers. Okay, then and their classification. Then let's see the alcohols first, then followed by phenols. Next one here is the ethers. Next one here is the aldehydes. Next ketones. Then carboxylic acids. Let's see. Then first one topic is here is the alcohols. So what is meant by alcohol is what? When hydroxyl group is attached with aliphatic carbon. Aliphatic carbon instead of one hydrogen. Okay, when the hydrogen is replaced by the hydroxyl group in aliphatic hydrocarbon, then that is called as alcohol. Then here is the alcohols. While giving the names for alcohols, here is a nomenclature. Then here is a suffix is ol. Ol suffix is used. Then yes. Common name is here is a alcohol. Then IUPAC name is while giving IUPAC, then ol suffix is added to the carbon chain. Then let's see. This is the compound methyl alcohol, CH3OH, methyl alcohol. Common name is a methyl alcohol. IUPAC name is a meth. Then one carbon is present here. Then here is a meth. Then here is a ol, methanol. Why? If it is CH4 methane, one hydrogen is replaced by OH group. Then simply here is a E, methane. E is replaced by ol. E is replaced by ol, then here is a methanol. Then next one is ethyl alcohol, CH3CH2OH. Ethyl alcohol is a common name. Then here is this is simple. If it is CH3CH3 ethane, then instead of one hydrogen, one OH group is present. That's why here is a ethane. E is replaced by OH, ol, then ethanol. Then next one, when the carbon chain is increased, numbering is given. Then in general, while giving numbering, then the nearest number, while giving the numbering for the bulkier chains, then the lower number should be given to the functional group. That's why the numbering is from this end, 1, 2, 3. Okay, that's why. So this is common name is N-propyl alcohol. IUPAC name is propane 1-ol. Yes, while giving the name is a propane 1, 2, 3. 3 carbon atoms propane, they can be linked with a single bonds propane. Then here is a E is replaced by ol. Yes, where hydroxyl group is present, that is first carbon. That's why propane 1-ol, propan 1-ol. Okay, or propane 1-ol. Then next one is this is the isobutyl alcohol. So this is a branching chain is looks like here is a branch like structure. That's why here is a isobutyl alcohols. Then 4 carbon atoms are there in this alcohol, isobutyl alcohol. They can be arranged as a branch like structure. Then is a IUPAC name is lowest number should be given. Lowest number should be given to the functional group. That's why here is a first number 1, 2. Here is a 3. Then yes, here is a 2-methyl propane 1-ol. 2-methyl propane 1-ol. Then next one is another one. So again these 4 carbon atoms can be arranged like this. Then this is a tertiary butyl alcohol. Then next one is a numbering according to IUPAC system. Again the longest chain should be taken as parent chain. That's why here is this is the second carbon. The second carbon is having one end is methyl group and the end is OH. That's why there is a 2-methyl propane 2-ol. So this is the IUPAC name. Then next one is a polyhydric or trihydric alcohol. This trihydric alcohol is 1, 2, 3. 3 carbon atoms are having the 3 hydroxyl groups here. Then common name is a glycerol. IUPAC name is propane 1, 2, 3 triol. Propane 1, 2, 3 triol. So this is the IUPAC name. Then again there is a alcohols. Alcohols may have the cyclic system. If the cyclic systems are present in the alcohols, cyclo prefix should be added. Then yes, let's see the examples. So this is cyclohexanol. Then next one is, here is another one, cyclic system is, but it is having another substituent. Then yes, the number should be given, the priority should be given to the hydroxyl group. This is a functional group, that's why the first priority is given to the functional group. Then the lowest number should be given to the functional group. Then here is a 1, 2. As a second position methyl group is there. That's why here is this can be written as prefix. That is yes, 2 methyl. Then next one is this is cyclopentanol. So this is about the alcohols which are having cyclic systems. Cyclo prefix should be added. Then next one, structure of a functional group. Then yes, alcohols are having the OH functional group, hydroxyl functional group. This functional group is attached with the aliphatic carbon. Okay. Then so this is the alcohol functional group, CH3OH. It is the preliminary, yes, very primitive alcohol. Then CH3OH. Then in this carbon is involved in sp3 hybridization. Then again, so this oxygen is also having also involved in sp3 hybridization. Okay. Yes, sp3 hybridized carbon is a hybrid orbital. sp3 hybridized orbital of carbon overlaps with the sp3 hybridized orbital of oxygen overlaps. Then here is this is a sigma bond is formed. This sigma bond is formed. Okay, in between carbon and oxygen, sigma bond. This sigma bond is formed by means of overlapping of sp3 hybridized orbital of carbon with the sp3 hybridized orbital of oxygen. Then so by means of overlapping, sigma bond is formed. This sigma bond length is 1.42 angstroms or 142 picometers. Then yes, in general is a CC bond length 1.54 angstroms or 154 picometers. But is a carbon and oxygen, the bond both are involved in sp3 hybridization, but the bond length is lesser when compared with the CC bond length. Okay, because there is a reason is these two are different heteroatoms. One is oxygen, another one is carbon. That's why is because of high electronegativity, then the bond length will be decreased when compared with the CC. Then next one, here is a oxygen and hydrogen bond length is 96 picometers or 0.96 angstroms. Then the bond angle in general, yes, here is a the bond angle between is a carbon, oxygen, hydrogen is 108.9 degrees. That is, it is slightly lesser than the bond angle, especially in sp3 hybridization. Okay, then 109 degrees 28 minutes. 109 degrees 28 minutes. In general, when the two atoms involved in sp3 hybridization, then the bond angle here is a 109 degrees 28 minutes, but here is bond angle is 108 0.9 degrees. Yes, slight difference is there. This is because of the repulsion between lone pair repulsions. Okay, yes, oxygen is having two lone pairs of electrons. In between the lone pair repulsions are taking place. Yes, because of the lone pair repulsions, the bond angle can be decreased when compared with the 109 degrees 28 minutes. So this is for the structure of hydroxyl group or structure of alcohol.